Okay, so hello everybody, I'm Pierre Cancier. So you may know me on ArduPilot, mostly on rover boards. So I'm working in a French company that it's a ArduPilot partner. So I worked at Skytech, but we just joined the group as usual. So I will try to present a little the group before presenting what we can do with ROS and ArduPilot, because they paid me to come here, so it's fair game.
Yeah.
So I will pass on the history of the group because it's still changing, and I just joined. In fact, I joined Skytech in October, so it's very new for me. And Skytech just joined as one group, so it's still in structuration work. So I don't really know everything about the company, but we are a really small company. We have 50 people around the France on 4 locations. So I work at Bordeaux, that's here, maybe you know, for the wine. There is the main center. The main center is in Paris, there's here, and there is another center in Nice, and the other one, I don't know where the city is in France, so I can show you on the map. So it's a little bit a shame, but that's it. So what we're doing, there is actually, let's say, 3 business units. Data analysis and acquisition. That's what everybody is doing with drones. That means photogrammetry, sensor survey, photo taking, and things like that. We're doing training for pilots because in France we got strict regulation to be able to have commercial application with drones. So we need some kind of light certification to be able to use drones. And after we're developing new drones. So that's my job at Skytech. It's engineering job on designing new autonomous solution for UAV and I hope UJ, that means rovers. So when we targeted market, it's not the consumer market like DJI. It's a market of niche that it's video surveillance, video protection with drones. So we get already 3 solutions. A fixed side wing, a plane. I don't know anything about the plane, so I won't speak about it. We got a T-Thread solution. So on the T-Thread, we will pass all the power and all the data. So it's a secured solution. And theoretically, we can have unlimited flight time, but we need to prove it because, you know, drone stuff, we can have GPS glitch and things like that, so it's not really limited. But it's working very, very well to stay on flight for a very long time with multi-copter. And what I'm really doing at Skytech, it's, can you see something? It's the autonomous UAV solution with the base station. So this is a base station with a drone that is completely autonomous for video protection. So when we got an alert trigger on an industrial place, the drone will automatically take off, go to the alert point, open a live video stream, and ask to the operator what he must do. And then he can come back safely to the home station and land. So there's a big challenge for precision landing in our time, and it's quite the same as maternity is doing, but even better. Okay, that's all for the company presentation. If you got more questions, I can answer it later. And I got some company paper if you want to know more. And feel free to contact if you want to work in Europe with us. Because, yeah, we're smart, so we don't have worldwide experts. So, the main things, ROS and ArduPilot. So I will start with the basic presentation of ROS, and after I will show you an example of what we can do, because it's a very large subject, so we can do many things. So ROS stands for Robot Operating System, but it's not an operating system, it's a middleware. For those that don't know what is a middleware, it's a kind of, it's like SDK, some IPs, some software that are between the application and the OS. So it's a lot of software on structuration APIs to allow you to reuse what you already done and make things simpler to develop applications. So middleware are largely used in plain industry for certification. So they get certification on middleware, and after they can do whatever application they want. And because the middleware is certified, they know that the application is safe, and they can pass all the regulation. And for robotics, ROS is kind of nowadays a standard, the standard middleware. Everybody in robotics will try to use ROS because the philosophy of ROS is to simplify all the robotic developments. So they provide many tools and use case and example and documentation to allow you to build a robot easily, even if you are not a software guy. I mean, yeah. The goal of ROS is to allow all the academics and mechanical engineer hobbyists to do robotics without knowing anything. That's the goal. So, why do we need a middleware in robotics? What happened before? It happened already. Currently also happened in many companies. That when you are developing software for robots, it's tightly linked to your hardware. Means if you change something in your hardware, you need to start again to make your programmation. So you lose time. It's very expensive for the company. It's long. So you can use a middleware. That will allow you to have a common code base between all your developments. It's easier to program. If you are a new engineer to the company, they just need to learn how to use the middleware, and they can start programming easily. But the problem with this approach is that your middleware is locked to your company. If you want to use something developed in another company, you need to adapt what you do to the other company, something like that. So it's really problematic. And that's why ROS is really interesting and got adopted very rapidly by all robotic enthusiasts, because it was open source and it was designed only for robots, but robots generally. And it allowed to make robots much simpler than before. So what is the ROS architecture? So if you look at internet, we will see that ROS is a keyword for everything. Everybody says, oh, I will do a robot with ROS. It will be incredible, autonomous, whatever you want. You can do whatever you want with ROS. It's not true. Not at all. The core or the heart of ROS is a publish-subscribe mechanism. So it's inter-process communication with some serialized data structure. And these data structures have been well defined for all robotic applications. That's the true force of ROS. And that's the only thing that's working well, in fact. So ROS, ROS it's very large, it's open source, it's free, so you don't need any license to use ROS. I mean, the ROS core, the core of ROS is free. You got some applications like slamming, path planning, that can be licensed. So you need to see everything. You get plenty of tools on ROS that ROS compatible. I mean, you can use OpenCV, some simulation, RODPilot, path planning, SLAM, whatever. And what was really useful on ROS is that you can use whatever language you want. I mean, there is API for every great language: C++, C, Java, JavaScript, Python. So it's really easy to make an application in C++, Python, using ROS to link everything, and everybody can work on whatever place they want on the robot, and it will work because you got the ROS infrastructure. Yeah. And mostly based on TCP/IP communication. So you need a normal computer. You can use it on a Peacocks, for example, for me. So it's light, but not that light. A bit of wording. So to make a standard of robotics, they try to simplify everything and bring new concepts, new words, so everybody can speak the same language. So this is the main wording of ROS. So instead of speaking of application and process, they are speaking about nodes. They got a master service that is the core of the communication service. We will handle all communication on ROS subsystem. We got a parameter server that is global. So that means all ROS nodes can access to other parameters. So it's very useful, but it can be dangerous too. But the message, so that's the data structure that will be passed through the publish-subscribe mechanism between the nodes. And we have mostly two kinds of communication exchange. So topics that are asynchronous exchanges, like I'm speaking, you are listening, that's the topic, it's asynchronous. And services that are synchronous. It's like if you ask me a question, I will answer. That's a service for us. And the last thing is the bags, that is the logging mechanism of ROS. So every communication, everything that transits through ROS can be logged. So you can have really big log if you are doing, if you are passing video or images. So this is just a picture to make an example of what a ROS ecosystem can be. So you have some topics, nodes that can publish the topics, so there is sending data. And if a node needs this data, you just have to subscribe to the topic. So it's the same thing you got on Pix4, if you know Pix4. And for the service, it's the same thing, but the node will ask a request on the service, and the node that creates the service will answer. Okay, some great tool. The main force of ROS, I think, is the binding with 3D simulator for robotics. So the biggest is gazebo simulation. So you may have seen I have done some simulation with gazebo and ArduPilot, and I will show you later. So it's very nice to make, everything you want on robotic with collisions, because on Seattle we don't have collisions. It can be problematic. It can be a problem, and on academic side, it's a big mess because they are always doing their own simulation on graph base, so they don't have collision. And I think that if you don't have collision on robots, it's not a real simulation because you miss a big part of the robotic issues. We got Catkins. Catkin, that is a tool for compilation. I mean, ROS, the goal of ROS is to allow everybody to make programs for robots. So they design a new system, a bit like WEF for ArduPilot, but it's not more powerful. It makes things simpler. So you do everything it's like a magic black box. You can clean something and it will solve the dependency. It will say you, oh, that line is not good, that line is not good, you need this package, you need this other package. So it's kind of very useful tool for compilation when you know nothing about compilation. We get RQT, that I think it stands for ROS QT. That is the only guide that is by default on ROS. So it's an all-purpose tool to see everything that is in ROS. And I add MavROS, that is the main Mavlink ROS translation system. Okay, so ROS is working, I will say, quite well if you are doing basic things. But if you want to do more advanced robotic stuff, like slime, path planning, multi-robot system, it's kind of hard with ROS currently. This is a problem because of the ROS architecture wasn't designed to be that generic. It was a fun project at start and become bigger and bigger and bigger. And it doesn't scale with all the capabilities it has. So the main problem on ROS, I think, is that it's a centralized architecture. If you lose the ROS master that's under all communication, everything crash. You lost all your system. So it can happen. So you get big weak points on your ROS architecture. The second problem that is a big problem for ArduPilot is that all ROS stuff are designed mostly for ground robots. So it's 2D space. So the default navigation stack is for ground robots. You can't. So it's a problem for quadcopter. You don't have avoidance in 3D space. It's not good. And the last biggest problem is the documentation and the quality of the package on ROS. Currently on Ubuntu, there's hundreds of packages that you can directly install on your computer to use with ROS. But the problem is that you don't know the quality of the softwares that were developed. I mean, most of work on ROS is by academics. So they do some kind of software that will work for their presentation, they will make a demonstration. It is working, but they don't go further. So they don't know the limits of the program. And when you are using their program, you see all the problems you want. Buffer overflow, whatever you want. It's very common on ROS that thing doesn't work as it should be, because there is no code review, there is no auto test, there is nothing like that. So it can be dangerous to use ROS without looking deeply in the code base what you are using. So to solve some of the ROS problem, they are working on the ROS 2.0 solution. The beta, the first release just came in January, and this solution is based on data distribution service. It will be more lighter. It can be embedded in peacocks. You don't have the weak points of the centralized communication. It's auto-discovery on node and things like that. It's real-time compatible. It's multi-robot system compatible. So it can look great, but I won't use it now. It's the first release. It's full of bugs. It's missed documentation. It's not as powerful as the first version of ROS. But
wasn't the intent of ROS 2 to be embeddable, so it's less powerful intentionally?
sorry?
You said a problem with it is it's less powerful, and it does less, but that's by design, I thought.
Yeah, it's because the true force of ROS is the ecosystem. I mean, you have plenty of packages that you can link to ROS. But on ROS 2, it's very new, so you have nothing. You just have the core of ROS, the communication system, and that's all. So you need to build everything to be able to use it with ROS 2.
So the community hasn't built up around it yet. The variety of tools aren't available. Even though it's less powerful, you just don't have the downloadable options that you have with ROS 1.
Yeah,
I think of it as ROS Mini, because ROS 1 is this beast.
yeah,
ROS 2 is designed to be less beast.
yeah, it's less based, but it's more professional. Right, more professional, and And, yeah,
ROS
it's,
Pro.
I think it's better quality. It's really impressive if you go to ROS 2 design. The goal of ROS 2 is very well think that they think very well what were the drawback of ROS 1, and they go further and they will bring something really great. I'm really enthusiastic for ROS 2, but currently I can use it because I don't understand how it's done. So it means what was good on ROS 1, it was easy, it was simple. On ROS 2, it's more complicated.
Oh, really? ROS 1's hard. Maybe more people use it if it's called ROS 2 Pro.
Maybe. I think Pix4 is trying to use ROS 2 in their layer. They say they will do it 6 months ago. I got no news about that. So. But I think it's quite hard to use it now. If you aren't a big programmer. So, before continuing to an example, do you have some generic question about ROS?
Sorry to go back to ROS 2, but you've said embeddable. How embeddable? How light is it?
So,
You've said ROS 2 is embeddable. Part of the goal of that transition to ROS 2 is to make it embeddable. So I'm guessing that means on MCUs rather than on Linux boards.
yeah.
How have they done that? How small is it for
I don't really know how small it is, but you can use it on, I don't remember the name of the chip on Arduino boards. Arduino Uno boards.
Mega?
Yeah, at Mega 8 or something like that.
Oh.
So very small at Mega.
Okay.
So the fingerprint is very, very small. You don't have all the features, but you can have the communication system with ROS 2 on very, very, very small chips. It's quite interesting. You can do like CAN bus, but with ROS 2.
Did ROS 2 do away with the TCP/IP requirement? Does it move to something UDP based or?
UDS?
Yeah, in fact, ROS 1, you can use ROS 1 with UDP too, but I think it's not the default, and I never use it that way. So maybe possible. Okay. So ROS and ArduPilot. Yeah. We got two words. We got ROS, that is proven for all robotic stuff, all robotic activity, but it's more like big robotics with this desktop computer. When ArduPilot, it's well proven for embedded platform. I mean, it's a fun presentation. It's very famous man, if you know, on the internet. Yeah. I think that ROS and ArduPilot are complementary. I mean, each one has its true forces and its true drawbacks. But we have a problematic, a big problem, is that ArduPilot only speaks Mavlink and ROS only speaks ROS. So it's two different languages, two different communication systems, and we need to have a way to make the communication possible. I know at least two packages on ROS that allow this bridge. So there is MavROS, that I think it's the best, and ArduPilot Bridge, that is a Python application. I never use it, so I don't know more about it, but it exists. And one problem we got is that ArduPilot only respond to Mavlink commands. So you can only sound Mavlink, do start command long, something like that. It's restricts compatibility with other systems, I think. But Mavlink is working quite well for me. So, how can we use ROS and ArduPilot together? ROS got all the big algorithms, SLAM, bus planning, visual odometry, things like that. You got algorithms that you can use with your own risk. Be careful. And on the other side, on ArduPilot, we got We got compatibility with all kind of vehicle. You can do rovers, plane, quadcopter, whatever you want. And you got something very important, that is safety. We got plenty of safety measures. We can know if you are leaking battery, if you have a GPS problem. And this is a true force for ArduPilot, because on the road side, you need to do that every time you need to make a robot. So we got this, it's working, it's proven, and it's a true force to bring that in ROS. And I know some academic works that are very, very happy to use ArduPilot and ROS. Because ArduPilot do its best with mobile vehicle. So, yeah, I made a research project as part of my thesis and my PhD on swarming with ROS and ArduPilot. So that's why I joined after ArduPilot, because I need to do many works on rovers. I got some videos I can show you later. But the point is that without ArduPilot and ROS, I wouldn't be able to do it, because I need the ROS side to do all the swarming, and I need a good basis on basic navigation, I would say, because without that, I need to implement all in ROS with my risk, and I can, yeah, when you get plenty of vehicle on the earth in the same time without real communication, you need to be sure that they won't collide, that they will just learn if there is a problem and things like that. So only ArduPilot can bring that on ROS side, or you need heavy developments. Yeah. So that's the big question that everybody asks on Gator and discuss. How can I use ROS with ArduPilot? There's really no difficulties. You just need to, no difficulties. You need to know ArduPilot, you need to know ROS. So you need to know the box to make it work. But after, you just need to install MavROS, for example. And it works out of the box. There's no configuration, nothing to do, it works. And I will show you a sample use case. Oops. So, we will do some...
Bigger font. Control plus. Big font.
This is Seattle, it's a rover. So I will just launch an instance, because it doesn't work with only rover. I got parent problems. So whatever.
We have big rovers at CMAC. Really big.
So what I have done is, it's a fake simulation. Yeah, in fact, it's something we can do with ArduPilot. We have a really simple simulation with Theta, and it's faster than doing this on Gazebo. You don't have to deal with our mechanism. So what I do here, I use Gazebo only as a plotter of acetal position. So we got collision on Gazebo, but it's fake collision. All the calculation is done on Theta. Yeah. So yeah, we got plenty, when you are using ROS, you got plenty of command line. Here I will use ROS launch, that is command line that will allow me to launch all my application, all my ROS application. So I will launch 4 nodes, 4 ROS nodes at the same time with the launch file. Launch file, well, you need to see on ROS documentation what is done. Oops. So launch my nodes. So I launched MavROS, I launched Gazebo. And I launched also a node that translates acetal information into Gazebo position. So now we got a big rover. So it's not the CMAC. I don't have the 3D model of CMAC.
Didn't recognize that building.
It's across the road and down.
Yeah.
So here is our Ardu rover. So it's a big rover. I don't do anything on this simulation. I just take some breaks on other ROS package and I make the simulation I make it yesterday morning, if you see it back. So here, we got a vehicle. If we want to move it, I make another application of ROS. So it's kind of what is done on APsync. So it's a web server that will launch JavaScript and HTML pages where I can control the rover. This is all ROS based. I just sudo apt-get install ROS package and everything on ROS. So I just designed these fake pages. Don't look the JavaScript code. It's a shame. It's a ROS in JavaScript. Yeah, behind the scene. So here we have a FPV view of the rover, and I made just a sample button for arming. So now the rover is arming. So, oops, it's armed. What is done? Here, when I click the button, I go to JavaScript logic that will send a message, a ROS message to MavROS to say, hey, it's a service, I think. Hey, do arm rover, and MavROS converts this into a Mavlink package and send it to Twitter. So it's very, very complicated for a simple simpler. It's just to show the point. And after I implement RC override on the fake joystick. So that's the kind of stuff you can do really easily with ROS and ArduPilot. Don't use RC override, please. Yeah. To show what is behind the scene. Oops. We will use RQT. Oops. I don't know if you can see the thing, but this is all the topic. We saw nothing, but this is all the default topics that we get with MavROS and ArduPilot. So when you are connecting MavROS to ArduPilot, you get all the binding of Mavlink. Everything that is sent by the ArduPilot is directly converted by MavROS in ROS topic. So we got here everything. So we get to see also simulation things. And what I will show you is the general architecture. Oops. So yeah, I don't know every menu, so that's why I'm changing. It's red. So this is my ROS application. The two packages I launched are this one. I launched all this with two command lines. There is MavROS that communicates with STL. So you don't have the communication here because it's not ROS. MavROS is linked to a WebSocket server that allows me to get back information from the JavaScript. So we can see here what kind of topic I'm subscribing and publishing. So I'm publishing a server to MavROS. No, wait, yes. This is publishing a server and MavROS is just subscribing. And on the other side, MavROS is sending STL state to the ROS bridge server. So I can know the error state on the web page. And that's the same for the other thing. So here, I get connection between MavROS and what I called Gazebo Ardu that just do the plotting on Gazebo, the STL plotting, and after. So that's the kind of stuff you get by default on ROS, and you can see it's just a matter of reading the ROS documentation and tutorials. So they are better than ArduPilot on that side because there's many tutorials on ROS. That I think is all from the presentation on ROS. Yes, simulation. What I have done for ArduPilot is I made some binding with Gazebo. So normally you can use full 3D simulation with acetal and Gazebo, but using data from Gazebo. So currently we just use UME data and position and velocity from Gazebo. I got a patch for to get GPS from Gazebo and rangefinder. Later we can make another patch for communication for RF communication that can be simulated to get two in Gazebo. And I tried to get this merged in Gazebo master, so we can just install Gazebo and have the ArduPilot plugin working. But it's kind of styling on Gazebo side, so need more rocks. So I do a Gazebo using Gazebo as simulator with some chains in acetal to be able to use it on multi-robot system because I need it on my teams. And Gazebo exploiter, so that's what you see today. You just put the position of acetal in Gazebo, and that's all I've done with ROS and Gazebo for now. And I hope to be able to do more. It's very useful for everybody. I hope you understand a little what I say.
Fantastic.
If you have questions, yeah.
Yeah, that's very good. Can you show us a little bit of what the your Gazebo Ardu looks like? Like you have to write a little bit of code to move topics from here to there, right? That seems to be a lot of ROS. Is you write like a little program that subscribes to this topic and then republishes to this topic in a slightly modified format. Or after doing some calculations. And I just
adapter.
Yeah.
Like a protocol adapter.
Yes.
Yeah.
You grab it out of this mailbox and stick it into this other mailbox.
Yeah.
And so there we go.
I don't know how to zoom.
Control plus or control alt plus?
No, it doesn't work.
Opening on a terminal with manual or something.
We can sort of see it. People see well enough. Well, no? It's just Python. Yeah.
It's not worth seeing. Just close it.
Important typography. If it wasn't screwed up, we should do microtype. Because that's important typography.
Yeah, make it full screen. There we are.
That's better.
Okay, so I use Python. Normally I do all my ROS stuff in C++, but here I use Python because it's simple. So it's very, very simple code. I go to fake classes, and I go to parameters. So we go to rovers that is named Iris. That's not an Iris rover. What I've done, it's here. What are my subscribers? So I got 1 subscribers. So I call a ROS by instance. So it's ROS binding for Python. I subscribe a topic that is called MavROS, local position and pulse. This topic is defined on MavROS as the position, the fused position from PKF, I think. So it's what is sung by, I don't know the Maven message, but it's Maven message that it's translated on ROS standards. So it's a post messages. The post template messages on ROS is got position, X, Y, Z, and orientation, plus the timestamps. Yeah, I don't use, I use only the position because, and the orientation too. So that's for subscribing. to publish quite the same thing. The syntax is very simple. I use ROS object. I will say I will publish on a topic that is called gazebo set model state. So this is a standard topic from gazebo. When you launch gazebo with ROS, you got this topic that is automatically created, and these two topics got all the model states. All the model you got in gazebo are published on ROS, so you can get back the information from the new model on gazebo, and you can kind of cheat on the simulation because you can modify the position. That's what I'm doing here. I just say, oh, move the object. So it's not a real simulation, just plot it, just move the object. And after, so that's for the configuration. Yeah, a problematic on programming when you don't know how to program is that you make a main loop and you don't know at which words your loop will loop. So generally, when you see some beginner code, they are doing some hello world loop, and it's use all the processor. It's 100% of the processor because there's no limits. So it's blocking infinitely. So ROS got a mechanism to handle that. So that's the right thing. I said, oh, okay, I want my loop at 60 Hertz, and it will loop at 60 Hertz. And ROS, here I use ROS to handle the shutdown. If I get send a sick term, ROS will close everything properly and close my application. And after I got two callbacks. That's for the publishing and the subscribing. So, what happens? The magic happens on ROS, in fact. When you get on the loop, on the sleep, in fact, there is the callback mechanism of ROS that triggers, so it will call automatically my functions because it's bound here. When I create my subscriber in my production, I say, okay, I want this topic. I want to subscribe to this topic with this kind of message, and we will do this action, this callback when you get a message, and that's what was doing for me. I don't know the magic behind, but behind it's serialization of the data. And so when I get the data, I just have to get back the position of the position of SCTL, put it in the model state. That it's the message for gazebo, and just publish to gazebo. Okay, move the model on gazebo with the data we get from SCTL.
Can you plot a small rectangle mission in that proxy and just can you see it auto navigate that in the gazebo? Yeah. We probably have to set home first.
You have to fetch the existing mission before you can draw WP list. Okay. Should be got a result there. Is it all up and running?
Yeah.
The console.
Set home first.
It should have home set. It's got a home icon, so its home is set. I don't think it's responding. I think something has stopped. You type, go to the console. Something is not running.
I think there is a problem. But ArduPilot problem.
There you go, now try it.
Try it now.
So this is marvelous. So that say also say, okay, we got to fly around.
Right, yep.
Okay, go. I don't know what will happen if we if we crash on some building. I think Gazebo will crash because I haven't done that yet.
It's whenever a bump.
But it's just plotting. It's horrible simulation, but it's good because you got a lightweight simulation with Seattle, and you can show, yeah. But I have done here.
The gutter pump, is that going to be sent back to ArduPilot?
There's a sensor reading probably.
But here we can send the sensor back to Seattle. If I put some LiDAR, some watchfinder, we can have the information back on Seattle.
Yeah,
So it was excellent.
Yeah, really good.
that's cool.
Is there going to, like, this is the sort of thing we get a lot of people talking about, oh, can you support ROS, can you support ROS? Is this the sort of thing that should be in the wiki somewhere, a basic introduction to get something like this working?
Yeah, I started working some pages on ROS, but yeah, we got too much stuff to do with my job, so
Yeah.
And I don't use ROS anymore in Skytech, so
Yeah.
it wasn't my previous job.
Pierre put a chunk of stuff on the wiki probably 7 or 8 months ago. Last year you put a fair bit of work into the wiki.
Yeah.
For ROS. So there is some stuff there.
Yeah.
So there is some stuff on how to connect ROS and ROS, but I think it's the base.
Yeah.
And after to set simulation, these aren't standard packages. This is only on my GitHub. I
Right.
can share it.
Right.
But yeah.
When's your flight out? Wondering how much time you have.
So I didn't understand the
When do you
question.
leave to France?
Grant's about to make you work.
Monday, I can show you this afternoon. I can teach you it really easy.
So on the wiki by tomorrow morning. Excellent.
If you can correct my English, it will be good.
Fantastic. Thank you very much, Pierre.